Friends, welcome to my YouTube channel. Dhanesh here at another interesting session on machine learning. In the last video, we were discussing about different types of encoding techniques in machine learning. We discussed about one-hot encoding, label encoding. In this video, I am going to have a comparison between on-hot encoding and label encoding. What's the difference between these two types of encoding techniques? This is a quote from Mother Teresa. There are no great things, only small things with great love. Let's continue. This is the 13th video on feature engineering. So label encoding versus on-hot encoding. There is separate videos for label encoding and one-hot encoding in my playlist. There I have given the implementation in Python as well. In this video, I am not giving the implementation part. Only the differences and the limitations of these two types of encoding and where they fit, those things I am going to discuss now. See, this is a very nice diagram. This gives the complete classification of the machine learning data. See, data can be classified into categorical, that is qualitative, and numerical, that is quantitative. Qualitative data, that is categorical data, can be classified into nominal and ordinal. Numerical data can be classified into discrete and continuous. Categorical data. Categorical variables represent types of data which may be divided into groups, example race, sex, age group, and educational level. See, sex can be classified into male and female, like that classification is there. Division is there, simple. Nominal data is defined as data that is used for naming or labeling variables without any quantitative value. Nominal data is named data which can be separated into discrete categories which do not overlap. See, a common example for nominal data is gender, that is male, and it can be female. Other examples include eye color and hair color. See, you need to understand categorical data is classified into nominal data. Nominal data is a categorical data. So next is ordinal data. This is the classification you can see here. See, categorical data, it is classified into nominal and ordinal. So nominal, categorical we discussed. Now I am talking about ordinal data means a statistical data type where the variables have natural ordered categories and the distances between the categories is not known. It is very important they are ordered categories and distances not known. For example, low income, socioeconomic status, low income, middle income, and high income. Education level, that's high school, BS, MS, PhD. We don't know the distance between them, but it is ordered categories. Income level, less than 50K, then 50K to 100K, over 100K, satisfaction rating. All these are all examples for ordinal. Then encoding of categorical variables. Why we are going for encoding in machine learning? Machine learning algorithms cannot handle categorical variables unless we convert them to numerical values. And algorithms performance depend, and these algorithms, whether it is supervised machine learning algorithm or unsupervised machine learning algorithm, the performance depends on how categorical variables are encoded. That's another important thing. There are many algorithms that support categorical values without encoding as well. This is an important point. There are some algorithms it is that the encoding is not needed. The algorithm itself it will take care. Categorical encoding is a process of converting categories to numbers. Different types of encoding techniques are one hot encoding and label encoding, binary encoding, frequency. These two we have the videos in the playlist. These two are the most important, and here I am giving a comparison. See, label encoding is also known as ordinal encoding or integer encoding. In machine learning, we usually deal with data sets which contains multiple labels. These labels can be in the form of words or numbers. To make data understandable or in human readable form, the training data is often labeled in words, right? It is inverse. Label encoding refers to converting the labels into numeric form so as to convert it into machine readable form. Machine learning algorithms can then decide in a better way on how those labels must be operated. See, labels are converted into machine readable form. For an example, I will give you. This is the data we have: country, age, and salary. So we need to convert this into labels. See, the output after encoding, the output is like this, because here 0 is repeating because Australia is repeating here. So a program can run it. See, I have separate video for label encoding. There I have given the Python implementation as well. You can watch that video if you need more clarity on this. This is the output. Here, the limitations of label encoding. Label encoding convert the data in machine readable form, but it assigns a unique number starting from 0 to each class of data. You saw that. This may lead to the generation of priority issue in training data sets. A label with high value may be considered to have high priority than a label having lower value. In the above example, the country names do not have an order or rank. But when label encoding is performed, the country names are ranked based on the alphabets. Due to this, there is a very high probability that the model captures the relationship between countries. To avoid this, we come up with the concept of one hot encoding. This is the drawback of label encoding. To avoid this, we are using one hot encoding. Now we will get into one-hot encoding. One-hot encoding is the process of creating dummy variables. In this encoding technique, each category is represented as a one-hot vector. I will give you an example. Consider data. This is the data we are having. It's a fruits and it categorical value and price is here. So how we will the output after doing the one hot encoding using a Python program also you can get it. This is the output we will get. See, apple, it is 1010. Then mango, it is 0100. Orange, it is 0001, like that. It is it's changed. See why it is apple 1 is repeated means apple is repeating here. You can see here. So that's why you can see here. Sorry. See, this one is repeated here. This is the way, another way of to avoid, or to to avoid the limitation of label encoding. We will use this one hot encoding. So the whatever limitations we discussed for label encoding is not here. It's not coming here. That is the advantage of one hot encoding. But limitations of one hot encoding, you need to understand there is limitation for one hot encoding as well, that we call it as the dummy variable trap. One hot encoding results in a dummy variable trap. Here, the outcome of one variable can easily be predicted with the help of the remaining variables. Dummy variable trap is a scenario in which variables are highly correlated to each other. They are, interrelated to each other. These variables are highly correlated to each other. The dummy variable trap leads to the problem known as multicollinearity. Multicollinearity occurs where there is a dependency between the independent features. Multicollinearity is a serious issue in machine learning models like linear regression and logistic regression. We have separate videos for multicollinearity. You can watch those videos. To overcome the problem of multicollinearity, one of the dummy variables has to be dropped. One of the common way to check for multicollinearity is the variance inflation factor. So there are separate videos for this as well. VIF, variance inflation factor. If you need more clarity on this aspect, you can watch those videos as well. That's all about the difference between label encoding and one hot encoding. Thanks for watching. Please like, share and subscribe. Thanks a lot.